All right, the next thing we're going to be looking at is counts. Like when we have categorical data, like remember, categorical data is like shipping method. Remember we said eye color, stuff like that. Shipping method would be one. You can select ground, second day, or overnight. And each customer is going to pick one of those, right? So we're going to count how many times they pick each one. That is collecting data on a categorical variable. So here's a frequency table for what shipping method was chosen. As you can see, ground gets picked the most because it's the cheapest, and usually people aren't in that big of a hurry to get their stuff, so they'll pick ground more often. So that's what a basic categorical table looks like. So let's take a look at some more examples here. So when we focus on the amount of something, we use the counts differently. For example, Amazon might track the growth of a number of teenage customers each month to forecast CD sales. So they're looking and seeing how much their customer base is growing among teenagers, and as you can see, it's growing a lot right here. Every month it's getting bigger and bigger, the number of teenage customers they have. So number of teenage customers is going to be the categorical variable here, and they're doing it by month. So the what is the teens, the who is the months. That's what they're collecting data on, the months. They're picking each month and seeing how many teenage customers there are for each month. When the values you want to study are quantities, those are quantitative variables, like the number of AP exams each of these people took. That is a quantitative variable because I could take the average of it. What's the average number of AP exams these students took? And I could add them all up, divide by 9 and see, right? So for example, how many AP tests will you take? That's a quantitative variable. It's a variable that has a number, and you could take an average on it. If you can take an average, that's quantitative. But you got to be a little bit careful because there are times when there's numbers, but they are not quantitative, they are categorical. And these are some good examples right here. These are all categorical even though they're numbers. Because what they do is they provide like a unique value to identify or categorize something, like a social security number. It's a number, right? Like it's a 9-digit number, but I can't what's the average social security number? That doesn't make any sense, right? Or ISBN, that's how you identify a book at a bookstore. You can't take the average on that. What's the average FedEx tracking number? That don't make any sense. What's the average person's zip code? That doesn't make any sense either. You see, that's a way to tell if it's actually categorical and not quantitative. So identifier variables cannot be analyzed. They can't be like averaged, or you can't take statistics on them, right? And are considered categorical. So be careful not to consider all variables in one case per category, like year or name, as identifier. Because sometimes you can take the average year, right? So they're not always an identifier variable. They're not always unique. So the why will help you decide how to treat identifier variables. We need the who, what, and why to be able to analyze data, but the more we know, the more we understand. When and where can give us some really good context sometimes. Like if you record something at a large university, you might get different data than you record at a small private college. I can give you some even better who's here. If you want to get a feel for how the average student at Ridgepoint does on the SAT test. Say you wanted to figure out what's the average score in an SAT test. The who's important. You need it to be random, right? If I were to go into the calculus class and take an average, I would get a way different value than if I went into some other class, right? Because calculus students are going to be the best at an SAT in math, right? So I can't just cherry pick who. I got to get me a nice random sample. And where you do it is different. Like at a prestigious school, the scores would be higher than at a smaller school, right? So the who is important as well. I mean, the where is important as well. And when can be important, obviously, right? Because things change. Like, if you record data of the Rockets when they were winning championships with Hakeem versus when they were a terrible team, in the early 80s, you're going to get completely different data on how good of a team they were. So when is also important as well. So how the data are collected can make difference between insights and nonsense. You got to make sure you collect your data accurately in a way that will make sense. Like if you do an internet survey, they're often useless because anybody can vote a bunch of times. Like you got just one person voting 1,000,000 times, completely skewing the data and giving you biased, worthless data. We'll get more into that in Unit 3, but how you collect data is super important. If you don't collect it correctly, it is worthless data. So the first step of any data analysis should be to examine all these W's. That's the key part of the think process. You have to examine like why and how and when and where we're getting this data. What can go wrong? Don't label a variable as categorical or quantitative without thinking about the question you want to answer, because those can go back and forth depending on what you're looking for. Just because your variable is numbers, don't assume that it's quantitative. Like the jersey number on a player, the zip code, the social security number like we talked about. And always, always be skeptical. Do not take data for granted. You want to know all 6 of those W's before you're sure about what you're reading, because it could be biased in so many different ways, and we'll go over that in class a little bit. So what have we learned during this? Statistics is about data, and it helps us understand the world. And we just seek to describe the differences, like what we can see in different data, what we can, what we can get from that data, what conclusions can we make. And data and information are in a context. Those who, what, when, where, why, how. You've got to know the context of data for it to be useful at all, to be able to say anything useful. And the last big point of this chapter was the categorical or quantitative. Categorical variables identify a category. Quantitative is like a measurement where you can take an average. Remember also, discrete has set numbers like 1, 2, 3, 4, 5. And continuous can have any number in between. Like 2.34785 meters is how far away this is from here to there. That is a continuous. A discrete would just have set numbers like a dice roll or something like that. All right, that is the end of Chapter 1. You should have all the notes on it. Now go ahead and try some of those practice problems, and I will see you in class.